Hi all, welcome to our channel Electromer. In this video, we are going to learn about phases and complex numbers in AC. This is the second part of the complex numbers series. If you are not clear with the basic concept of complex numbers, please kindly watch out the first part and come back to watch out this video. The link of the video is in the description below. Now we are going to deal with some of the arithmetics which is mixed with the polar and rectangular form of the complex numbers.
So this is the questions 3 minus j4 plus 10 angle 44. So here there are two complex numbers in two different form. This one is the rectangular form, this one in the polar form. So here we have to do the addition. So to do the addition of subtraction, as I said to you earlier, we have to convert the complex form into the rectangular form, because for the easy purpose we have to convert all the complex number into rectangular form for the addition or subtraction purpose only. So here this one is in the rectangular form. So 3 minus j4. So this polar form need to convert into rectangular form. So if I convert this one by using the scientific calculator, the answer will be 7.19 plus j into 6.95. So now as usual, here there are two rectangular form need to add. So separately we have to perform the addition. 3 plus 7.19 will be 10.19. 10.19 here minus 4j plus 6.95j. So altogether 2.95j plus j into 2.95. So this is the answer. So let's move the second question. 22,000 plus j13 divided by 3 angle minus 17. This one is in the rectangular form. This one is in the polar form. To do the multiplication or division, the simplest way we have to follow is we have to convert all the complex form into the polar form. So we have to convert this one into the polar form. So if I convert by using the calculator, the polar form will be 22,000 angle 0.03 divided by 3 angle minus 17. So now here there are two polar form need to be divided. So 22,000 divided by 3 will be 7,333.33 or something. Okay, I put 34 angle. Here we have to subtract 0.03 minus 17. So altogether 17.03 plus 17.03. So this is the question is 95 minus 12j. This is the rectangular form. So we have to convert this rectangular form into polar form. So for that purpose we are using the scientific calculator. So here is the scientific calculator. Here I will explain you the way of converting the complex numbers by using this scientific calculator. Here we have to type this complex number. To do the complex operation, we have to select the mode operation. Then the second option is complex. So we have to click the complex operation. Now the complex mode is activated. Now we have to type this one, 95 minus 12. For the j we can put this I symbol. So we have to click this button. So close the bracket. Now what we need to do is we need to convert this one into polar form. Therefore again we have to click the shift, then 2. Then after it is asking the convert operation mode. Here the third number is in the polar form and fourth number represent the rectangular form. Here we need to convert the rectangular form into polar form. So we need polar format. The polar format indicated by number 3. So you have to select number 3 and press the equal. Then it will indicate the final result. So the polar result will be 95.754 angle minus 7.199. So now we can write the answer 95.754 angle minus 7.199. This is the answer.
Phasor transform. Phasor transform is used to solve problems that involve sinusoids. It could be such as AC voltages or AC currents. We use this phasor transform method. Actually, the phasor transform is used when we deal with the arithmetics with sinusoids. For that reason, the initial step we have to use is we have to transform sinusoids into complex numbers in polar form. Then after, we have to solve the problems using complex arithmetic and then transform the results back to a sinusoid. The sinusoidal waveform. So here is the way we use to generate a sinusoidal waveform through the vertical projection of rotating vector. So here the value of the waveform of the magnitude is changing with the angle, so that it is generating the sinusoidal waveform something like this. So I hope this animation video will clearly explain you how the vertical projection of rotating vector generates the sinusoidal waveform. Phasors. A phasor is a rotating vector whose projection on the vertical axis can be used to represent a sinusoid waveform. So this is a phasor which holds the sinusoid equation as Vm sin alpha. So here the Vm is the maximum value of the voltage and sin alpha. So here the length of the phasor is amplitude of the sinusoid. The length of the phasor Vm, which will be equal to the amplitude of the resulting sine wave. The angular velocity of the phasor is omega. Here is the angular velocity of the phasor. So this angular velocity of the phasor will determine the frequency of the sine wave. Now let's learn about how to represent AC voltage and current by using phasors. So for that we need a sinusoid equation. So here this is a simple sinusoid equation. Vt equal to V peak into sine omega t plus 30. So with the help of this sinusoid equation, we can take out two values. So we can determine two values, which is V peak and offset, phase offset theta. So the V peak means the maximum voltage or the amplitude of the sine wave. So here this one is the V peak value and phase offset theta will be 30. Here this is the phase offset theta. So if we have V peak and phase offset, then after we can derive the phasor. So here we have V peak and phase offset theta. So with the help of this V peak, we can determine Vrms. So if we have the V peak value, we want to convert the peak value into RMS value, just we have to divided the peak value by root 2. So before that, the Vrms mean voltage of root square. So the definition of the Vrms, which the equivalent DC value of a sinusoidal current or voltage is 0.707 of its value. So with the help of V peak, we can determine Vrms just by divided by the root 2. Then after we can write the phasor. So the phasor will be Vrms angle theta. Again I will explain. Here we have the sinusoid equation Vt equal to V peak sine omega t plus theta plus 30. So here this one is the peak value, this one is the phase offset. Here we have peak value, then we can convert this peak value into RMS value. For that one, we have to divide this peak value by root 2. So we have got RMS value. Then after we need phase offset theta. Directly we can take out the sinusoid equation. Here is the phase offset theta. Now we are going to learn about how to represent AC signals with complex numbers. Here the phasor representations can be viewed as complex number in polar form. Here what they are telling is we can represent the phasor by converting the polar form of the complex number. So here is the AC signal which has the value in the sinusoid equation Et equal to root 2 Em sin omega t plus theta. this AC signal can be converted into the polar form of the complex number. So here is the way we can convert these AC signals into the polar form. Here we have root 2 EM. This value, this EM or E peak value can be converted into RMS value. As I said earlier, if we divided the peak value by root 2, we will get the RMS value. So the ERMS to root 2 EM by 2. So the root will be cancelled. Again we will get the EM. So according to this value, to this equation, the ERMS will be equal to EM and angle theta. Here the phase offset theta can be directly taken from this equation. Here is the theta. So with a simple way we can represent a complex number, or we can represent the phasor by the polar form of the complex number. Example problem. Here there are three currents which represented by the sinusoid form. I1 equal to 20 sin omega t milliampere, I2 10 sin omega t plus 90 milliampere, I3 30 sin omega t minus 90 milliampere. Here there are three currents are given in the sinusoid form. Here the question is we have to determine the equation of total current IT.
So here is the question. Here the total current IT is coming towards the north and it is divided by three parts. Here I3 is flowing through this inductor, I2 is flowing through this capacitor, I1 is flowing through this resistor. So here all three currents equations are given by the sinusoid equation. We have to do the phase transform. So the I1 will be 20 sine omega t. So if I convert this sinusoid equation into complex number, the I1 will be equal to, here this is the I maximum value. So the I maximum value divided by root 2, we will get the RMS value. So the I1 RMS will be 20 by root 2. So that will be equal to 14.14 and angle theta will be 0. Likewise, we have to find out the I2 also. The equation for the I2 is 10 sine omega t plus 90. So likewise, we have to find I2 RMS value. To find the I2 RMS value, we have to divide the I peak value by root 2. Here the I peak value is 10 divided by root 2 will be equal to 7.07 and angle theta will be plus 90 degree. Likewise, we have to find I3. I3 will be 30 sine omega t minus 90. Here I3 RMS will be equal to I peak value which is 30 divided by root 2. That will be equal to 21.21. Approximately 21.21 and the angle minus 90 degree. So our question is determine the equation for the I total. So the I total will be equal to I1 plus I2 plus I3. Here all three equations converted by polar form. So here the I1 will be 14.14 angle 0 plus the I2 is, the magnitude value is 7.07 angle 90 degree plus I3 is, the magnitude value is 21.21 angle minus 90. So if we add all these polar numbers or polar form, we will get the value. By using the scientific calculator, we can perform the addition directly. So now if we add these three values, we will get the I total. So the I total will be 20, approximately 20 angle minus 45. So the simplest way to do this arithmetic is by using the scientific calculator. So if you need to do this manually, first of all, here all are in polar form. The operation is addition. That's why we have to convert this polar form into rectangular form, and separately we have to perform the addition. Then after we will get the result by in rectangular form. Then that rectangular form need to convert into polar form. So that is a longest way. So the easiest way is directly we can type this value in the scientific calculator. Then we will get the final result something like this. Approximately 20 angle minus 45. This one is the magnitude value. This one is the angle. So here they have asked to determine the equation for the I total. here we have got the complex value for the I total. Again we have to perform the transform. Now we have to convert this format into the sinusoid form. So this one is in the complex form. This one need to convert into sinusoid form. So I total will be I peak into sine omega t plus theta. This is the format. To find out the I peak value will be I RMS into root 2. Here the I RMS value is, here I mean I total. I total RMS value is 20 into root 2. So the answer will be 28.28. So the equation for the IT will be 28.28 sine within bracket omega t. Here the theta is in minus. So the minus 45. So this is the equation for the I total.
Phase difference. The phase difference is angular displacement between waveform of same frequency. So if we want to determine the phase difference, the condition is the waveform should be the same frequency. If angular displacement is 0 degree, then the waveform R is in phase. If angular displacement is not 0 degree, then we can tell that one as out of phase by small amount of displacement or the certain amount of displacement. So if angular displacement is 0 degree, then we can tell that one as in phase. If angular displacement is not 0 degree, then we can tell that one as out of phase. Phase difference. Here there are three type of wave patterns are drawn by three different conditions. So if we look at each and every one, here you can see that first one is voltage and current are drawn by two different colors. So here both patterns are in same frequency and there is no any other phase displacement in between V and I. That's why we can call this one as voltage and current are in phase. Here if you look at the B part, current I is leads by some amount of phase displacement. That's why we can tell as I leads voltage V. Here the I lags the voltage V by some amount of phase displacement. That's why we can tell as current I lags the voltage V. So here is an example. If V1 equal to 5 sine 100t and V2 equal to 3 sine 100t minus 30, V1 leads V2 by 30 degree. We can tell as V1 leads V2 by 30 degree. Formulas from trigonometry. So sometimes signals are expressed in cosine instead of sine value. So if you face a question with a cosine value, so the first step we have to do is we have to convert the cosine value into sine value. For that one, we are using the basic trigonometric knowledge. So here are some basic trigonometric. Here cos omega t plus theta. Here we have to convert this cosine value into sine value. Therefore we have to add with the 90. Therefore sine omega t plus theta plus 90. Likewise here sine omega t plus theta. Here we have to convert this one into cosine value. Therefore we have to subtract by 90 degree angle. Therefore sine omega t plus theta equal to cos omega t plus theta minus 90 degree. Here cos omega t plus or minus 180 will be equal to minus cos omega t. Sin omega t plus or minus 180 will be equal to minus sin omega t. So with the help of this basic trigonometric knowledge, we can convert one form of the value from the another form. Likewise, if we have dealing with a questions, their signals were expressed in cosine value, we can convert that cosine value into sine value.